Hi guys. So today what I'm going to do is a system design mock-up interview. So basically what I am going to share today is how to create a secure network in the cloud for a distributed or containerized application, and then how to expose that application for developers through a VPN. So first, let's write down the requirements. This is an Excalidraw. It's often used in system design interviews that I've encountered so far this year. And what I'm going to do first is write down the requirements. So first, here's our prompt. Create secure enterprise network for internal employees to access containerized application in the company's cloud. So just so that you know, for the sake of posterity, our users are going to be developers that work at the company. The security level is for a developer / stage environment. So note the trade-offs here. And the data we have, we need to be SOX compliant. And the rate of access is about 100 users. We have 3 main external databases or storage sources, so like a bucket, Postgres, and something that would process the Parquet files, SQL files, Postgres, a bucket, and possibly a Lambda for logs, right? Okay, so what else do we care about? We care about the users, the security, the data, and just to put a note here, remember to talk about how to make it resilient, scalable, and recoverable, right? Okay, because with data, we care about accuracy and rollback more than we do uptime. Okay. Obviously, we want uptime, but that's what we get. So because I'm making this up as I go, we are going to easily create some problems for ourselves as we go along, and I'm going to be talking about AWS services. So first I'm going to represent our flow of data, right? So first we're going to have the users trying to access our let's just call it airflow containerized application, Great. Fabulous. So it doesn't need to be perfect. So let's talk about the flow of how they will access and the components of the network that we want to include. So first, I would assume that our users are using a VPN, right? A VPN tunnel. With this VPN, we have then the authentication layer somewhere. So what is our authentication? In AWS, there are several layers of authentication. We have first the, let's say, Okta or an SSO identity. We have something like OIDC, which SSO and Okta identity provider, those are the same thing. OIDC. Then we have something like a IAM role with an IAM role policy that is associated with the token that gets accessed. Maybe we have then we have some kind of firewall. Maybe we have an intrusion detection system. That monitors network logs on VPC, and so I'm getting ahead of myself, but the firewall can be attached to a couple of different endpoints, so I'm going to leave this here for a second. So let's go from then our containerized application to our users, right? So I'm assuming that this Airflow application is sitting on a EKS cluster, right? Because it's either either EC2 instance or a containerized environment like Elastic Container. So for now, to confidently say Airflow is much easier to deploy and scale on an EKS cluster. I'm going to say EKS. Okay, so EKS has multiple regions. So let's make this bigger. But to flatten our, Excalidraw is difficult unless you have a mouse. There we go. Can we make it smaller? No, we cannot. Let's see if this is connected. Let me get a mouse. All right, we'll just leave it there. So let's talk about our endpoint. So just so that you know, these are, we first have a private subnet and a public subnet, and there are 3 within the region that we have our EKS cluster, and then we have just a rough virtual private cloud. Now I could go into details of this containerized environment if you wanted to. We needed a public and private subnet because everything within the EKS cluster is going to be a 10.192. Or any side of IP addresses that are managed in our application or in our cloud provider. So firewall sits here, authentication sits here. We need another element like how do we access our storage? We'll just call it a cluster of storage. Just say we have a database, Postgres, etc. So from here, we're going to add something called a dedicated storage proxy. Probably overkill, but it helps scale when the requests become higher than the standard limit. We only have 100 users, so it's probably overkill, but it also adds another endpoint to allow us to sniff, capture logs, and secure. So I'm going to call it a storage proxy. Right? And here we can attach a security policy. We can attach a basically it would filter by domain, it would filter by the types of traffic with a security gate. And we can also put firewall and shield, right? Shield is allows us to detect any anomalies. So even though this is in the same cloud, it is possible that we have external storage, right? That's not in our cloud. So anything that is external could possibly be, right, in a different VPC or external data source, right? Because Airflow captures a lot of different types of data. Okay, so we have users. They're going to go through a VPN. There's authentication. There's a firewall. You're also going to need something to expose right here called a load balancer. So call this a load balancer. EC2. Now, okay. Here's the trade-off. LB, right? We could do a gateway API. It's better for scaling. We could do a app load balancer, or we could do a network load balancer. Depending on how granular the traffic is. Oh, man. Okay, that's kind of small, but hey. So let's look at this. We have our application here, and let's kind of troubleshoot and go through and think about this. We have users going through a VPN tunnel of their network. We have to make sure that they have authenticated their session first, right? So, hey, I'm going to log in. Hey, are you who you say you are? All right, great. Through this tunnel, you have a IAM role associated and a token associated with the cloud provider. Otherwise, if you're not coming from this set of IP, let's see, right? You're going to put your firewall here. Because if you're not part of this subnet, let's just say like 32.2.2.5, right? So, or another region is 12.2.2.6, whatever, right? So this VPN, it has a specific IP address. So the firewall can block any traffic, public traffic that's not from that IP. So that allows this authentication, which is usually a third party, right, to do the negotiation and give you a token. So once that session is established, you're good, right? So you're past the perimeter. Then you say, hey, I want a specific endpoint, right? So I want, let's say I want airflow.internal.com, whatever, right? And I want this endpoint login. So this endpoint is hosted here, right? So this load balancer, there's a DNS internally that, let's just call it DNS service. Okay, let's get rid of that. So the service, the domain service, route 3, DNS provider is going to say, oh, I know where that is. This goes to a specific address. Right? And then we're going to have our session go in, maybe, right? All right, I'm authenticated. Now I go to the route. I can't spell. This is route, gosh, 353 DNS. That manages our domain name, right? It's like, oh, okay, I know where you are. You're here. So I'm going to hand you off to this load balancer, right? And then the load balancer says, are you authenticated? Are you one of these IP addresses? Because there's a security group on that load balancer. And then it says, okay, do you have a legit certificate? It's going to go back. It's going to say, do you have the certificate? Yep. Oops. Okay, and then it goes back to our load balancer and says, yes, great. All right, I'm going to pass this traffic through here to our containerized application, right? Okay, and then you're in. Now, once you're in and you're talking to the application is going to manage the stuff that you want to fetch. So say you need to fetch data from the main storage because you're looking up some users and you want to see, okay, how many users in our product have logged in the last 24 hours. So perhaps our storage is where our logs are. It's going to fetch that data. It's going to run a pipeline. Oops. Gosh. And it's going to say, here's the data. And then Airflow is going to say, oh, I need more resources. And it's going to say, I'm going to scale out, right? Because you're not the only user. As this traffic increases, it's going to take more time. So let's think about this. We've got an EKS cluster, a containerized application. There's one more piece I want to talk to you about, which is the network here. This is called a Kubernetes network policy. EKS has several layers of application and networks within it, right? So we have even a separate namespace. We have a network policy on pods, on storage, in different connections, even within EKS, because EKS can have more than one application hosted on it, and it can have traffic going all over the place. And we don't want users to have direct access to it. So this network policy allows for SSH traffic, HTTPS traffic, and let's say the Kubernetes ports that talk to each other, like Kube API, etc., and other things like that. And then storage traffic, right? So you have different types of storage. You're going to have port storage, which is like FTP traffic, S3 traffic, Postgres traffic, right? And they all have their own ports. But for every storage type, you're going to add to that security group, or you're going to add to that ingress egress on our security groups within the proxy, within the EKS network policy, and then also within the security group on the load balancer. Now the IPs are going to change as well as this traffic goes through each of these endpoints. And it's really important that we allow that traffic. So your firewall is probably not going to need 50, might need 53, port 53. It might need storage, right? Because our firewall isn't just here. It's all over our private network, right? So I'm just doing that to show you the scale. And that's the gist of it.